everybody. Welcome to Rebooting Web of Trust Demo Night. Today is a special demo night. We have a speed demo night dating. Yeah, so we have a lot of fantastic demos from all over the world. And as we squeezed a lot of demos, it's a kind of speed demo night. So 5-minute presentation, 4 minutes for the questions. And the first speaker, I would like to give a very warm welcome to Maaike van Leuken. And Maaike will talk about TNO EASSI and SSI Wallet Gateway from eSSIF-Lab. Maaike, stage is yours.
Thank you. Welcome everyone. I will be kicking off today's demo with a demo on TNO Easy. It is a gateway for SSI wallets, just like Molly or Stripe is a gateway for payment services. And the problem we're trying to solve is that there's a large amount of wallets. And this is very nice for the holder because they get to be autonomous in what wallet they choose. But this is actually also very difficult for issuers and verifiers to provide support for all of these wallets. Because they're working differently on a technical level, this means that offering support for them is different for each wallet. This means that it is costly. And there's multiple solutions for this, and we made our own. So this is what Easy is. Easy is the orange little block. So we have connectors here on the bottom that are specific for each type of wallet. And in the top, we have a simple API for verifiers and issuers to connect to. And this brings us to the demo. So in this demo, I'm going to play issuer and verifier. So first, I will be issuer. And I will play the government and issue myself a passport. So here you see my name and my length, which is not completely accurate. And I will send this to my wallet, and Oscar will support me in this. So here we see the typical TNO Easy overview. So basically, we get to choose whatever wallet we prefer to use. So today we'll be using eSSIF. So now Oscar can scan this QR code, and a connection will be set up between my wallet and his wallet and me as issuer. Yeah, great. So Oscar connects to the Easy Gateway. And when I click OK, a credential will be issued. But of course, Oscar has to approve of this. So if Oscar approves of this information, which is also here on the left, and he approves, obviously, then he clicks accept. And this credential will be issued to my wallet. So in the wallet right now, on the left side, is a credential listed. And it's also displayed on the screen. And now I also want to verify this passport. Well, not the passport, but my identity. So let's say I want to work at a flex work company. So they want to verify my identity. And I can, again, so here you see the typical TNO Easy overview. You can pick whatever wallet you want to use. But before we issued the credential to eSSIF, so we will do that again. So again, the connection can be set up. Yeah, so it's connected. And when I press OK, there will be a request to prove the identity. So Oscar can now choose whether this information is suitable to share. And he can click send. And obviously he did, because now his identity has been verified, or actually my identity. So that's the demo. Thank you all for your attention. So maybe to sum up, TNO Easy is a gateway that makes it easy for issuers and verifiers to offer support for a variety of wallets.
Excellent. Thank you, Maaike. So, questions from the audience? There must be questions. Yeah. Manu.
So I saw in the demo there was a list of all the wallets and you had to pick one. Yeah. Was that just for the demo or do you have to actually make that selection? Meaning like what happens when there are 30 wallets?
Yeah, right. So then you have this NASCAR problem that you want to solve. So then maybe you can have a kind of drop-down menu, or because you set up the connection first, it knows what kind of wallets you have, for example, and it just shows the options that you have.
More questions? Mirko? Yeah.
So we know there are already a lot of protocols out there. Are you aware of that? For example, DITCOM1, DITCOM2, has it an impact when I'm on the page that I have to filter it before, or do I have to, as a user, think about what do I really need or what do I have to choose, or am I free to use it?
You're free to use whatever wallet, and this wallet is typically coupled to a protocol. So that's like a one-to-one mapping. Does that answer your question?
Yes, thanks.
Okay.
Yeah, Maaike, thank you. Big round of applause to Maaike. And then as the next speaker, we have Mr. Lal, and he's talking about data exchange agreements, and he also contribute to the eSSIF-Lab. Mr. Lal, over to you.
Good evening, everyone. So I'm going to introduce you to what we call as a data exchange or a DEXA protocol. The fundamental problem that we are solving is twofold. One, for most companies in this part of the world, at least in Europe, we have a problem that every company that is processing personal data has to be compliant to GDPR or similar regulations. So how do these companies prove that they have adhered to the articles associated with GDPR when it comes to personal data protection? The second aspect is essentially about human beings, that is individuals. How do individuals get auditable proof of every data transaction they do? And they can control the use of personal data at any given point of time. So these are the two essential reasons we introduced DEXA protocol that ensures that every data transaction is trustworthy, auditable, and immutable. So in my demo setup today, I have a test lab, so wherein the DEXA agent is inbuilt in the Aries DITCOM messaging. So the DEXA protocol is embedded as a message as a decorator in every DITCOM message that happens between the issuer, wallet, and the verifier. On the other side, I have the travel company, that is the verifier, which receives any kind of, say, credential that is issued and shared by the individual. In my example today, the test lab, I've taken the example of a COVID data that has been issued by the test lab that is carried by the individual, and the individual is sharing, for example, during check-in process. So now to my demo. So on the left side, I have my data wallet as a holder of the wallet itself, and on the right side, I have a demo setup starting with a test lab, which provides you with connectivity. So the first thing that you do essentially is, as an individual, I connect to the organization. So I scan the QR code, establish the connection, and it says connection already existing because, okay, I seem to be having a bit of a problem. So let me try again. Yeah, so it says connection already existing because I've already connected before. And once I've established the connection, the test center, after doing the test, can issue me certain credentials. So let me call it LAL demo. And I issue the credential. So the credential is issued to me, and I think there's a small little bug. Never mind. So I have a data agreement that is presented to me. And as you can see, there is a data agreement policy that I can view. And in that policy, it is clearly specifying the purpose for which the data is being issued to me, etc. And I have a auditable proof that this is signed by the company. And I have a green lock symbol that says that the issuer is already verified by the underlying platform. So once I agree and accept the transaction, so the certificate is stored in my wallet. And imagine a situation where I'm traveling abroad and I'm in the check-in desk of a travel company. So that's the third tab over here. So the check-in desk, I have to share my data that's being requested by the verifier. Again, what they've done is essentially created a data agreement, define it, specify the purpose for which they're using the data for, etc., and feed it in and present it to me as a QR code, for example. And I'm here scanning the QR code for sharing my personal data. A data agreement screen pops up, and as you can see, like it's requesting. It's a travel company based out of Stockholm. It's requesting for my name, test results, and test date. And you can see the data agreement policy that is over here. And the reason why you're seeing 3 different cards is because I've earlier connected and I've earlier been issued 3 different COVID certificates. And here I have the data agreement policy, which says the purpose. And you can see that, again, I have a verified proof of the verifier that it's a legal entity or a valid verifier out there, which has gone through the process, which is typically a DPIA to formulate the data agreement. So once I'm happy with the terms, I confirm the exchange of data. And the information is transferred to the test center now. At any given point of time, I as an individual is able to go to my shared history. I can see that the transaction has happened 10 seconds ago to a travel company, and I'm able to clearly view what information has been shared for what purpose. And I can also audit the data policy that I've signed. Here again, you can see all the GDPR-related mechanisms. And you can also see that it's been originally signed by the controller and countersigned by me as an individual at any given point of time. So that's pretty much my presentation for today.
Wonderful presentation.
Thank you.
Again, questions from the audience. I have 2 questions here. Joe.
So my apologies if I just missed this. At the point in which I share the credential, is there an opportunity for me to see the data in the credential before I share it?
Yeah. Yes.
Okay.
Yes.
Thank you.
It was there actually in the data agreement itself.
Hi. What happens after the 3 days, or it mentioned 3, are expired? So the period is expired. So will that consent be automatically withdrawn?
Well, in this particular case, it's more like a transaction that has been carried out at that particular moment of time. So it's an obligation for adhering to the data agreement is with the data using service, in which case it's a travel company.
More questions to Lal? Mirko.
Yeah, you showed that there's the purpose displayed, so I can see how the data should be used. Is there any way to save that? For example, I'm scanning the QR code and I'm seeing they're trying to get data from me, which they are not allowed to do. So I have some kind of proof that I can go, for example, to some kind of, not government, but officer that I can say, hey, here somebody tried to gain information they're not allowed to process?
Yeah, so if the whole idea is that every data agreement is signed and countersigned by the parties involved in the transaction. So that data agreement, signed data agreement, is fully auditable and can be shared to any third party, such as, for example, an auditor. So and the signature that you saw, which I was showing in the data agreement, is what ensures the validity of the agreement itself.
One more question over here, Rix.
Yeah, rather than hallucinating about this, what is the practical consequence of a data agreement actually being audited? What does it mean? Who suffers any consequences?
very tough question for me to answer that. I would say, so the whole idea itself is to create a trusted ecosystem. So this is like, the proposal itself is that hopefully there can be certain governance and mechanisms that can actually be built in that make sure that these things are adhered to. So it's in a way, it's very similar to how the world works today, right? If there's a legal agreement that is out there, it is the obligation of the parties that are involved to make sure that they adhere to the agreement.
Yeah. Follow up. These are electronic transactions.
Yeah.
They happen all over the place. In the Netherlands, the authority, the privacy authority, only has 2 hands and 5 other people with. So how does this work in practice? Do we foresee some electronic means to do that? Can you comment on that? Or otherwise?
We haven't really reached that far. So as part of the data exchange agreement protocol, what we are really trying to do at the moment is really enabling trust within the ecosystem. You know who the issuer is, you know who are the verifiers, you make sure that every transaction is auditable in every possible way. So hopefully we can create some framework out of this going forward.
Excellent, Lal. Thank you. Thanks for sharing all your insights about data exchange agreements. And now over to the next presenter, Caspar. And Caspar will talk about SSI, NFC, smart contract, smart card, login, and access control. Caspar, stage is yours.
My name is Caspar Roelofs from Gimly. And at Gimly, we are very much focused on enabling SSI over NFC. NFC for 2 reasons. As an alternative to scanning QR codes, because QR codes are not always don't always work well for those that are, for example, visually impaired, or sometimes it can be quicker to just tap your phone to a NFC reader, just like tap to pay, go towards tap to ID. That's on one side. On the other hand, NFC also opens up the use of NFC smart cards as a alternative form factor, if you will, to using a smartphone, because using smartphones is not always possible because not everyone has a smartphone, or sometimes you don't want to use a smartphone. Maybe it's not practical, it's not allowed. So that's why we've been working on using a smart card as a SSI hardware wallet, basically. And the second part is what this demo is about. In this use case, it's actually used as a physical identifier for access control, both in a physical environment, but here I'm using it as a two-factor authentication to log into an employer portal. So in this demo, my name is Caspar Roelofs, and I've just been hired by Cargo Express, an international company, as a cargo control center manager. Of course, we still need some legacy systems here to put my name in the database. I've gone ahead and already done this, actually. So here's Caspar Roelofs, the new hire. And now I'm going to send the employer, Cargo International, is going to send me a physical access card that I need to activate in my mobile app. And actually, I've gone ahead and already added this NFC card. Oh wait, this is in my app. To my wallet over here. And the next step will be for the employee to go to the employee portal. If I would try to sign in now, it will ask for my employee ID credential, which I don't have yet, so I won't be able to log in. I first need to go to the onboarding setting here. And here it will be asking me to share some of my information because they need to verify that I'm actually that new hire. I'm absolutely okay with sharing this information with my new employer. And in that case, what's happening now is the employer backend is issuing an employee ID credential to the DID of this smart card. Now, an important detail to understand what happened there is that this smart card actually contains a wallet, a public-private key pair that has been generated within this smart card. So the card contains its own DID, and it will be able to sign presentations, credentials, just using a tap of a card. So now I have a employee ID credential in my wallet, and I will want to copy that to the card in order to have that credential also stored on the card. As we can see now here, I have this employee ID credential, which the blue icon says it's stored on the card. Then what I can do now is I can finally log into this employee web portal environment, simply clicking signing in, and this is going to use SIOP v2 login process. It's going to ask for my employee ID credential. And since it's issued not to the DID in the app, but it's issued to the DID on the card, it's going to ask me to sign the presentation with the card. And that's the partner that created the NFC chip. Login success, and it should redirect me to the web portal, which now lists my own employee data. So this basically was the demo to show you that you can use a NFC smart card to sign verifiable presentations, verifiable credentials. Use that in this case as a two-factor authentication. Ultimately, we want to take it a step further, because right now we still need the mobile phone to actually generate the verifiable presentation, which is then signed by the card. The next steps will be to improve the business logic on this card to be able actually to generate the presentation itself. And that's going to be a major next step, and I very much look forward to working on that.
Caspar, you brilliantly combined hardware and software. Yeah, thanks for the nice demo. And questions to Caspar. Oh, I start over there with Paul.
So my question would be, where is the verifiable credential actually stored? So what's on the card? Is it only the key, or is it also the credential? Because the typical smart card has like 80 kilobytes of data, so you're pretty limited on how many credentials you can store.
Yeah, a good question. The data storage in this card is actually a bit bigger. You can store up to around 40 credentials on it. So it's stored on the card itself. In this particular use case, where you're still using the mobile phone to generate the verifiable presentation, you could also just keep the credential on the mobile phone. But in the use cases where we want to use the card as an access card with smart locks, you obviously need to have the credential on the card, because maybe there are other solutions as well, but that would be stored on both the card and in the app.
So what kind of crypto capabilities could the card have? Like, for instance, if you have you want to selectively disclosure some claims, for instance, would the card be able to do that, or how does the user communicate that?
So this particular card actually has a lot of cryptographic capabilities. It's actually designed as a cryptocurrency hardware wallet. So it supports all kinds of cryptographic curves, including now also the BBS signatures. So that will be also a next step to implement zero-knowledge proofs with that possibility. Yeah.
Yeah, this was the question I was going to ask. So what signature algorithm do you use, and what credential format do you use?
Sorry, could you repeat on for you?
What signature algorithm do you use for creating the present, or for creating the signature for the cryptographic holder, proof of possession of the holder, and what credential format do you use?
So right now we've been using the ETH-R DID method with the SEC 2561 signature. Is that right? I'm not the most the best at it, but I think I got that right. But you can choose. You can also use the RWOT 2551 and yeah, pretty much any DIP method that works with the cryptographic capabilities of the card.
Caspar, thank you. Now the next speaker is Robert Mao, and he will present a DIT Connect live demo. Robert.
Hello everyone, my name is Robert Mao, and I'm going to present something similar, but the focus is different. What I'm presenting is called a DID Connect. So DID Connect is inspired by Facebook Connect and OpenID Connect. Basically, it's a UX library, and to let the app developers easily integrate those verifiable credential, verifiable presentation easier into applications. So if you come to the website, so there's a playground. So basically the playground is using a very popular tool called a storybook. Almost every front-end user, they know that. So basically the storybook is essentially it's a document, but it's a visual document. To use the DID Connect, you just need to, if you use Node.js, it's just one line of a npm install, and then you can implement this in your code. So here, for the DID Connect, we provided a few components, and the major part I'm going to present is called a Connect. So basically, this is the one. There's a bunch of different stories here. Each of them is. Oh, hold on, sorry. Each of them is basically one of the use case. The use case basically have different parameters. As you can see for the story, you can see the source code of each of the story. Oh, what happened? My computer froze. Okay. Anyway, so each of them is a different story. The story basically have the different code of the different parameters. So here, for example, I can do a very simple one, which is basically just a request connected to the wallet, and it only is a DID. So the password only need to provide for the first time, and then the wallet is going to stay there for a few minutes. In this case, this is pretty simple. I just need to only require a DID for myself. So once I agreed, so basically the code can print the DID. Right? So in another more complex code case, I need to request for a user profile. Basically, ask for verifiable credentials that contain some of more of the information from the users. For example, here in the wallet, I already created different profiles. And one is a test, another is myself. In this case, I'm going to provide myself. And once it's created, from the code, from the JavaScript code, they get all the requests and response back. So we implement different type of the verifiable presentations, include something which is kind of integrated with the blockchain. For example, in this case, it's going to request for an NFT. So this is the typical case. For example, if you are in a DAO, you have an NFT that proves that you are a member of the DAO. In this case, this application I'm only open up for the member of the DAO, and the wallet going to let the user select a few of the NFT that in the wallet. So in this case, I just randomly pick one of the NFT, and so the code will get it back. They can then verify if the NFT is a valid one for the application its own logic. It's also possible that it's not an NFT on the blockchain. It's just a verifiable credentials that's stored on the wallet. Another typical case is sign a piece of a text, or sign a digest of the signature. For example, you have a file, you want to verify if the file is original, you need to have a signature of this kind of hash. There's other use case, for example, is in the blockchain. You need to request the user to sign a blockchain transactions. So in this case, the wallet is going to receive this request, is going to render the transaction visually for the user to understand what this is request to. So in this case, I can confirm that. So the code will get back the signed transaction with the signature. So there is two different here. One is a request for a payment. Request for payment basically say the application asks the user, say, hey, you need to pay something. You need to send some crypto to some certain account. So the difference between the request payment and the request sign for the transaction is one is going to broadcast the transaction and actually get back the receipt that the payment has actually made. The sign for the transaction is only sign that transaction, so the application can decide if I need to get more signatures or I can broadcast this on the blockchain network to finish these kind of transactions. So there's another few kind of for example, there is a multiple claims. In this case, a more complex application, they can say, hey, I need to request for the user's user profile information. I also need to request for the user to send me some tokens, to present me some NFT. So basically, I can do these multiple steps all together. In this case, I presented my user profile, which is a self-claimed credentials, and also an NFT to prove that actually I have that NFT. So basically, this is a very simple user library. The purpose is to let the developers to very easily to integrate the DID into their applications. The goal is try to make this application just a UX libraries. It's supposed to be work with any protocol, any wallet. Of course, different wallet vendors need to implement a few things to hook this up. So I can totally see if there is a possibility if we can have your wallet selectors integrated here, so the developers, they don't need to worry about anything. They just have this one-line code, and it works.
Robert, thank you.
Yeah.
Questions to Robert? Aha, questions over there. Thanks. Quick question, quick answer.
So do you use any libraries from diff or other projects, or is this an implementation from scratch? I guess what I'm trying to understand is, what was the inspiration behind creating this library?
So this library itself has no dependencies for itself. It's just its only dependency is a React. This is completely creating some kind of reusable user interface and for the developers. Suppose different wallet implementation should implement some callbacks to hook up with the wallet itself. So in this demo, we hook up with our own wallet, which is a web wallet. You can see it's from a browser. Suppose implement other wallet just to implement the.
Does this are all these messages following? Are all these messages following some of the standards that are defined, or how does your library understand what's the request content? Yeah.
So basically, this is the UI library. It only presents the user interface. And how to, what kind of wallet, what kind of protocol is up to it's like a driver. If you implement driver for this UX library, and then it's supposed to work based on the drivers. Make sense?
How does it know what to show in the wallet?
You need to, so you need to hook up your wallet code with this.
And then you can call one, you can show one of the screens depending on what you want to do, right?
Yeah. So basically, I have a few callbacks on the Reacts, and you just Yeah.
Excellent, Robert.
Thank you.
And now we have Saida. And Saida is talking about.
Is it not filled out?
DIT science, global DIT data analysis, right?
Absolutely.
Excellent. Saida, stage is yours.
Hi, everyone. I did not really prepare an interactive demo for you in the sense that we will scan QR codes and I will show my app. But what I'm about to show you now might apply to all of you who have an actual demo or everyone else in the audience. Because what we did at Danube Tech was analyzing global DIT data. So maybe you're wondering, okay, there's all these different DITs and DIT methods, but how many are actually used, or how many are used in a certain time period? Well, I'm going to show you now. We split up the DID methods basically on test networks and main networks because we thought that, okay, maybe test networks could somehow have a prediction on activity on the main network. So this graph basically includes all the DIDs on the test network. And what you, for example, see is, one add thing here. It's cumulative count. So it's not counts, they always increase since it's cumulative. So what you, for example, see here is, I'm very sorry for the colors if you can already see the distinction. Self-staging had some activity, I would say, in June 2018. It stagnated a bit, and then in June, I would say 2020, there was an increase again. Well, unfortunately, we don't really have the data for all the other mainnets to show if there is a real correlation. In this case, you can see, self mainnet had some increase, not too much, I would say about 1,000. Ion mainnet was increasing quite a bit, and that's interesting because here, the blue curve, as you see, shows an increase around beginning of 2021. And here you see, maybe a bit hard to see, say June 2021, there is an increase. That's in time plots. Then verification methods, something else we analyzed, just to be on the same page here. We resolved a DID, or you can resolve a DID, and you can see the DID document. And in the DID document, you can find this type here, JSON WebKey 2022. And what we can see is that, for example, the solve DID on the staging network has a 50-50 distribution of these different types because they're not really free to choose. But in the IM mainnet, there is quite some variety of these different types. Yeah, whoa, I hear. As you can see, JSON WebKey 2022 is used quite a lot. But as I said, there's a quite high variety. There's also the EASSI pre-prod DID method, also has some quite high variety. I'm not gonna mention those. You can look yourself. Ion testnet, you better read it yourself, sir. Some with 84%, and then there's again some distribution, I would say, for the other types. I just go on because we have 5 minutes. Another thing we analyzed was DID document errors. So this graph just shows you if there was any error indicated by 1. So in the BTSR testnet, there's just 55% of DIDs. So of all DIDs we're talking about, right? It's not just some part of a DID. So all BTSR DIDs on the testnet have like 50% of them have an error. And which error are those? Shown here, there's 80% of JSON LD errors. Some DID document errors, dereferencing errors, and verification method errors. No errors were found in the DID syntax or version time. But for IM mainnet, there's 100% error. And you're all wondering, where does 100% come from? Well, again, JSON LD errors, some verification method errors, that's okay. I give you some more time to look at this. Apparently that was quicker than I thought. Another interesting thing we found, I want to conclude with, was duplicate keys. So you might all think or know what this means. I indicated the key with just a number key 3. But as you can see here is that there were some DIDs which were not the same. They look very similar, but if you look close enough, there are different DIDs on the ion test network, and they had the exact same key. The same was found for EASSI. So again, EASSI DIDs, which were completely different, the same key was found. So that's, I would say, problematic. I hope you all have learned something from some graphs I showed you. If you have any questions, let me know.
Lots of data, and that's important.
Was
we
it
need
5
to work
minutes?
with more data. Yes, absolutely. Thank you.
Sure, to be in time.
Questions to Zaida? Lots of questions.
Sure.
Where do we start? Here?
I'm not sure I understand this one because I thought the key name was just an alias and different DIDs can reuse the same key alias, right? Like just the key errors thing. No. The last bit, right? Or
Yeah, the last slide.
yeah. So if you have like keys -1, that's just an alias within this document. It doesn't need to be
Sorry, this
globally
one you mean?
unique.
This one you mean?
Yeah.
Yeah, I did, but okay, I didn't put it because it was like this string, but sorry, that's what I mean. Yeah, it was an alias, yes, but they had the exact same. I mean, you have to believe me for that.
They have multiple keys in the same document called the same thing?
What
The same public key is, because you can have a different knots on all of these, so it's the same public key.
They reused the same key across multiple DID documents, and you really shouldn't be doing that.
Yeah, exactly.
But there's nothing that stops you from doing it.
But they're showing that they can, it's a bad practice.
Yeah, okay.
People are doing this really bad practice.
Got it, okay, yeah.
Developers.
Go.
Yeah.
20 euros. 20 euro. No.
Okay, just
Sorry,
real
go
quick.
on, yeah.
No, this is great data, and I've been looking at similar data. So I'm just curious here, when you're measuring 60% or 5% or something, you're talking about the percent of DID documents, not the percent of different keys that you see are this type. You're talking about over the usage of documents, even if the same key was used to sign 10,000 documents. I don't know if you might have looked at all.
Sorry, you were talking about this.
No, not this one. No, not this one. But and maybe I'm misunderstanding. But back on the usage charts, I'm just curious. This isn't a big problem. But back on the usage charts, when you're saying that
sorry, time.
Yeah. Those ones there, for instance, or those ones. It could be that the same DID was used to sign 20,000 documents, and it could be that there was 10,000 different DIDs that signed 10,000 different documents. And I'm assuming that you're counting it per document. No.
Yeah, so exactly. This is the global data we're analyzing. One note here. So what could be what we didn't really filter out here was that maybe there was a DID present and it was used for update or was updated. So in that case, it was kind of twice. At this moment, we didn't really filter it out. It probably wouldn't have changed the graph that much, but exactly, yeah.
And I don't even know if that even happens. I did sign a bunch of
Update can happen, but it's I think not happening that much at the moment that will really drastically change the graphs, but quickly.
Quick question.
For future work, I'd really like to see how many rotations are done on each of these.
Rotations?
Yes.
We'll talk about
or
that later.
revocations, or all the different things. Okay. Not creation, updates.
Okay, yeah.
Excellent, Zaida. Yeah, thanks for all the data.
You're welcome.
The science and lots of it. And now over to Isaac. Isaac will talk with us about the eSSIF-Lab project, the Train demo, and Train is about trust frameworks and APIs. Isaac, over to you.
Okay. Good evening, everyone. So today I'm here to present our project on eSSIF Train, and my name is Isaac Henderson. And so what does Train address? So Train addresses the trust and governance challenges which are currently in the SSI ecosystem. Although we have standardizations on VC and DIDs, but there are yet many number of DID methods available, and also the interoperability is very less. So how can we achieve this using Train? So Train currently verifies the inclusion of issuer, so it verifies the authenticity of the issuer, whether it's part of any trust scheme or not. So, and it uses the existing globally accepted DNS or DNSSEC anchor for this process, by which it allows to create distributed trust list around the internet, and also it gives the user the control over it. And it allows the verifier to, the trust decision always remains with the verifier. So whoever configures the verifier can host this trust list or the trusted list or trust registry, and it is not any centralized thing. So this one is inspired based on the work from EU lightest project, which is called lightest, so which was happening from 2016 to 2019. And how do we integrate train with SSI ecosystem? So that is shown here. We have a couple of components in the infrastructure, the ATV and the trust list and the schema. And how does the verifier of SSI can use this train API to achieve this? So currently, this is the architecture which we show this. So basically a schema diagram, how we can use the DNS infrastructure and the pointers and the URI records to achieve this. Since they are globally discoverable, and also you can not only host always your own trust list, but also you can point to different trust lists available by your partner company or things like that. Thereby you can also reduce the redundant things. And currently we also use the standardized format of trust list, which is the EASSI trust list format of TS119612, which contains a lot of metadata. So it's not just storing some public keys and hosting the thing somewhere, but rather it contains details pertaining to the information of issuer and also the service information, for example, related to schema information, for example, by which the verifier can restrict just only to take certain information what the verifier is respected to take, by which you can minimize the data control and things like that. So yeah, so what are the configurations which has to be done at the issuer side? So currently we show these configurations which can be integrated in the VC using the terms of use attribute, and also at the verifier side, you can just need to configure this corresponding issuer and the trust scheme pointer which you trust. Thereby, you can query the details and require the results. So I'll just show a small interop demo which we are currently working on. So it's not a completely working demo. So we are currently working for a global COVID certificate network along with partners from Linux Foundation and SimSoft Solutions. So they were responsible for creating this UI. And so, for example, the interoperability can be achieved among different nations, where different nations will be hosting their trust list at their premises. And you can use, so this is not a centralized trust registry. So each German trust registry is responsible for hosting their trust list, and Netherlands their trust list. So this is something for populating and finding to show. For example, when you click on Netherlands, you can find what are the trust service providers and the keys and stuff like that stored in this particular scheme actually. So currently we have a couple of information available, but it can be extended based on number of parties actually. And just the Swagger output, so how this verification status of the Swagger looks like, so how it can verify different issuers using different schemes by looking into whether it's available in this corresponding trust scheme or not. Yeah, thank you. So that's a short demo.
Trusted issuer infrastructure. Yeah, Isaac. Questions to Isaac? I have a question over here. Yes, thanks.
Yeah. I guess the obvious question is the vulnerability of when you lose your domain name because you didn't pay for it, or for other reasons the domain name gets transferred. And do you have a mechanism in place? Because you have a number of URIs there with sometimes different domain names, and is there a mechanism to make sure that if one of them, got taken over, that's known and somehow gets revoked, or what's that?
Yeah, we use the DNSSEC mechanism to prevent that actually DNS spoofing, because by which the chain of trust is always maintained. And also we have this TLSA mechanism by which we store the hash of the trust list signature in the DNS records, by which we also verify the integrity of trust certificates. So,
but if the guy legitimately lost the name and another guy really bought the name and then put pointer records in there, in the real name.
In the DNS record.
Yeah, in the real DNS record, but he just pointed them somewhere else.
We believe that the corresponding organization, or they have the control of DNS, and no one can come into that actually. So we trust the DNS zone. So who is having that? So the organization, because no one can enter that. So we trust that anchor. Yeah, exactly. Yeah, sure.
There's another question over there. Let me just pass the mic. Why would no one pay the DNS here? Last question, quick answer.
Did you use like a certain TTL value or something in these DNS records to make this work? Was it really low? Did high values work? Like was the TTL of the DNS records like affect the performance of this type of setup, or was that a thing that mattered?
No, we didn't have it check those performance-related issues actually yet. Yeah.
Isaac, excellent, yeah. And now I would like to introduce my colleague from Spherity, Konstantin Tsabolov, and myself, and we both will talk about trusted issuer list, also known as known authority list, yeah, and that's one of the white papers. And let's look into what's happening here. This is an implementation of a trusted issuer list, and first of all, we assume there's a governance body. Yeah, in our presentation today, the governance body is called Open Credentialing Initiative. It's a trusted industry governance body. For example, for the pharma supply chain, they all trust this governance body. And what we would like to show, what a trusted issuer list is. Should we do the GitHub?
Yeah, I actually can share the QR code so everybody can.
Oh yes, we have a QR code here, and everyone can scan it, and then basically also look in what's going on in the GitHub.
Yeah.
And I guess we can show this diagram.
Sure.
As well. And yeah, what do we have? So we basically have a Web3 front end. And this Web3... Now we have the QR code.
I'm just letting people to scan the QR code.
Yeah.
And I will let you to see the picture as well.
Excellent. So we have a Web3 front end, yeah. So this trusted governance body, such as the Open Credentialing Initiative, they have their front end. They have some governance rules, some thresholds rules, quorum rules, 3 out of 5, 6 out of 7, whatever the rules are. And with these quorum rules, they are managing a smart contract, in this case on a Ethereum blockchain. And this smart contract is representing the known authorities or the trusted issuer list. And all the companies that are part of the quorum rules, they basically participate with their wallets in a voting process, which means when the smart contract logic needs to be updated, there's a voting. When data in the trusted issuer list, known authority list, is being updated, and new authorities being added, and other authorities being removed, then the governance body or the representatives are voting and sending signed transactions to the blockchain. And now we do a real life demo. Konstantin, over to you.
Yeah, so actually this is my first time performing on a stage, so please bear with me. So yeah, let me demonstrate the proof of concept which was created by my colleagues in Spherity. I tweaked it a little bit just to be in the colors of rebooting. So yeah. So what we're going to do, we are going to add Carsten as a state keeper. So as was described, only state keepers can change the list. They can add authorities or trusted issuers, as we call them inside Spherity, and also remove them. Yeah, so for that I'm going to copy Carsten's Ethereum address from here, and I'll create a proposal. So, yeah. We are using MetaMask, but yeah, that's just the technical implementation detail. Yeah, it's not free, by the way. Yeah, you need to pay for Ethereum transactions. And also, yeah, as you might know, Ethereum is not the fastest blockchain, so we need to wait here, because actually now a real transaction is performed on Ethereum blockchain. Yeah, the RWOT11 one, the test network. Yeah. Just while we are waiting, okay, we are not waiting anymore. There's a proposal. Now, because, let me update this page really quick. The quorum at the moment in the contract is set to 80%, but because we have only 2 state keepers at the moment, so only 1 yes is needed. So I'm going to vote for that. And again, yeah, Ethereum, the slow one. So yeah, again waiting. So now the transaction is going to be performed in Ethereum, and the smart contract is going to add my vote to the voting process. So now the quorum is reached, so I'm going to enforce the proposal. So, and again, yeah, as you might think, yeah, we again need to do an Ethereum transaction. So Yeah, while this loading, I just wanted to note that we are using in this demo the web3.js library to communicate with Ethereum. So, yeah, it was not created by us. So, as we can see, the Ethereum address of Carsten's wallet was added as a state keeper. And I guess that, should we show also the, okay, yeah, then.
I just added a DIT, yeah, and I confirmed it with my MetaMask wallet, submitted the transaction, we wait a bit, and I added a DIT called DIT RWOT, with a DIT method RWOT, hello.
Yeah.
Let's wait until the transaction is being submitted and confirmed, and then we basically, I as a new state keeper, basically are about to add a new trusted issuer. Yeah?
Yep.
The RWOT organization.
Did it succeed? Still waiting?
It should be fine. Completed.
Yeah, I cannot see it.
On my side, it's done.
Okay. So.
You only have 60% if 2 people vote.
I just want to add that for the sake of simplicity, we didn't add the voting on the process of adding an authority, but as you might imagine, it's the same. We could add that also. So I think that's it.
Yeah, you refresh and then we get the questions, I guess. Yeah.
Yeah,
excellent. That's it. Yeah. If we would have done the voting, more transactions.
Thank you.
Real world. Trust issuer list, known authority list on the blockchain smart contract. Good stuff. Questions?
Sorry, I'm just ready to curmudgeon. And this isn't just for you. This is for everybody out here using QR codes. So the thing is, I mean, like, if you have any kind of security and, like, you tell, like, for example, your drivers, if somebody calls you and asks you for your secret key, don't tell them. People call the drivers and they say, hey, I'm from so-and-so, can you give me your secret key? And guess what? They tell them. And so I'm just curious, like with QR codes, it seems like all you guys with QR codes, like there's a big vulnerability because you can't even tell people like, well, make sure it says this.com on the top. You just see a QR code. And if I knew you were going to do that, I could have gone with a marker and changed that thing and you guys would all have scanned it. So it just seems to me like, is anybody having this issue with spoofing QR codes? Is it happening yet? Yes. It is a defense?
Yeah, I think this is a side topic here, but with spoofing QR codes, people are kind of thinking about having signed QR codes and then verifying signatures. I think there are a couple of things. Yeah. And I think you see these attacks, yeah, like I'm driving through city and there's some tourist information QR code and it's kind of direct to a malicious site, drive-by attack, and then being kind of forwarded somewhere else. That's pretty straightforward attack vector.
I just wanted to bring it up to all, because I noticed they were just a common thread, not just your demo.
Absolutely. Yeah. So secure QR codes, companies are working on this. Yeah. Excellent. Questions to trusted issuers. There must be at least one question. Mirko.
Yeah, does this approach scale? So what is the limit when I want to increase the number and the number, let's say I want to put every company from Germany in this list, then I would be about 1 million entries. Does it scale or do I need some other approach like a typical web service where I query a more performant database?
So, yeah, as I said, this was implemented by my colleagues, but I can only guess that the only limit is Ethereum smart contract limits. So as you can see in the GitHub, the smart contract actually is there. Let me quickly find it. Internally, this is organized as a map. So I don't know, to be honest.
I think
the
scales,
technical
and
details.
the question is, we don't need to scale it because if you have an industry domain use case, I have a handful of trust issuers, less than 10 or around 10, and then we don't need to scale it. Yeah, I think.
Yeah, but I would say that the question is totally valid. Yeah, because we immediately think about like scaling up. What if we have like I don't know, thousands or hundreds of issuers?
Well, I mean, my question was very closely related, which is what is the cost to store the state? So is the state being stored on the chain, or is it being stored off chain? And does that mean, as you reach hundreds, that it costs thousands of dollars worth of gas to do? So.
I guess so. I guess that the Ethereum specialist would answer that better, but because I've never worked with Solidity. But yeah, the important point is that reading is free. For whoever wants to check if like an issuer or an authority is on a list, that's free. But for the party which hosts the list, it might cost something.
And final question.
Not a question.
Okay, a comment.
Excellent. One of the approaches is you combine what we just saw before with what you're doing, and then use networks of trusted issuer schemes or trust frameworks. That's how people do it right now in the real world, in the legal world. So talk to me. We can make this, join it up, and actually have a scoring system.
Cool. Yeah, just maybe one more note today in the working group, because actually these days we are working with Manu and other guys on this topic. So in the end we agreed that maybe even a combination of all the methods will be the best solution here. But yeah, step by step.
And now a very big applause for
Thank you.
Konstantin. Thank you. And our next speaker is Alex Blom. And Alex Blom, I worked in telecommunications with voice over IP and zip protocols, all this kind of stuff. And now Alex will talk about identified communications. Alice calls Bob, but is it really Bob? Yeah. Alex, over to you.
So we did an eSSIF-Lab project. It's called SSI Comms, adding SSI to internet communications. And Animo, sitting over there, joined us, an AG project. They were responsible for the SIP part, and the money came from eSSIF-Lab. And we're at the top, of course. Okay, so this is the application. This is a flawless presentation. And we're still not even at the live part, so you're in for some fun. So this is the application. We have a business layer surrounding the two modules, a SIP module and an SSI module. SIP module comes from AG projects, and the SSI module comes from Animo.
I'm sorry, could you speak up a little bit? I'm just having a little...
Sure. And we quietly go to the next slide. There we are. And this is how it works. We first have a SIP invite, and we redirect and we get an acknowledge. So that's a classical way to start a SIP session. With one change, we also, Alice asks Bob whether he can do SSI. So if Bob cannot do SSI, we will not go on to the next stage, but we'll just do a simple SIP session, and that will be it, and we will not be able to identify each other, Alice and Bob. And that's an important way to approach this problem, because there's other ways to approach it, but this approach means that it's backwards compatible. So you can use your old SIP phones and call these SSI SIP-enabled clients, because they'll just find out that the other party is not able to do SSI, and you can keep your old voice over IP phone system. So that's, I think, a big advantage. And the other advantage is that we have a lot of SIP features at our disposal that we do not have to invent again. So we can do SIP chat sessions, we can do SIP video, we can do group calls, we can do anything, because it's already there. And then we have the identity layer on top as a topping of the cake. There is another approach to this where you start, if you want to combine internet communications with SSI, you start with DITCOM, and then within DITCOM you start to build your communication. But that's, to me, I know there's even people here, there's companies that do this, and there's people here, I think, that also like this approach. That's the way they go. It's okay. I think both methods are valid. But like I said, the backwards compatibility of this approach is an advantage. And the other advantage is that you can start by setting up a call. So there's no QR codes if you are afraid of QR spoofing. There is no QRs because what happens is that you exchange the out-of-band message over SIP. So this is Alice calls Bob, and Bob wonders whether she's really Alice. And then what I'm going to show you is the next use case. And this is Alice calling Bob and asking herself who's Bob, and Bob has the same misgivings about Alice. So I've got 2 Android phones. If anybody knows how to show an Android screen on a Mac, please let me know. I don't know I don't know how to do it. So put on your glasses, because I'm gonna do it. So here are Alice. The username Alice was already taken. So we have Mallory on this side, and we have Bob on this side. So there we go. Oh, wait. So now we're going to call. And there she is. It's Mallory calling. Oh. This is the curse of demos. Okay, so they've done the beginning of the diagram already, and they've received notice that they can now verify each other. Oh wait, I have to turn down the sound. So they're both verifying, and so here we see that Bob is really Bob. As you can see, it says Bob. It's a self-attested credential, and Mallory turns out to be called AJ Blom, and because it's an IDENT credential, so it's really the bank details of a living person. Okay, so so that's the end of my demo. Another use case we did, which shows that this method has some use to it, is we worked together with Visma that created a mandate service whereby Bob shows a QR code with which Alice can go to the mandate service, which then issues a mandate to Alice, if you can follow what's going on. So in our case, we set up the session between Alice and Bob verify each other, and then Bob sends a text message with the content of the QR code that just needs to be tapped, and it establishes the DITCOM connection with the mandate service, and then she receives the mandate. So that's another way to do it.
Alex, thank you. 1 question over there, 2 questions over there.
So your exchange, were you using SIP with SIP TLS and SCCP or SRCP as well? Because what you could have if you're doing unencrypted is you could replay the SIP session and use that to replay attack, right? Might be, I don't know if my question makes sense. So basically, SIP is normally an unencrypted protocol.
Yes.
Which
yes,
means
it gets
if you send the
unencrypted
traffic,
from the
So if you send the traffic, you can replay attack it. Especially because in voice over IP, you're hopping over
multiple
different providers,
and you lose
right?
the encryption on the first hop.
Right.
Yeah, that's
so
right.
Were you using SIP TLS or one of the
We could.
encrypted protocols?
We could. We
Okay.
could. It doesn't change the situation.
But no, in SIP, I believe if you can't do TLS, it falls back. So you could force somebody to fall back to unencrypted, right?
Yeah.
It's a downgrade attack.
It's a downgrade attack. Yeah, it's a downgrade attack. It's a downgrade attack with a possibility of then using it for a replay, which. But I think it's a great, fantastic idea. But if you can verify that the other endpoint isn't able to successfully downgrade and only then do the DIDCOM, I think that will make this even better. Because in SIP, you can force the other clients to downgrade, and that's a bit problematic.
Okay. Okay.
Yeah, no, I just wanted to ask if in the demo what you showed is normal phone call from one phone to the other, or if it was like a custom application that you were using to demo.
Sorry, come again?
It was a custom application that you built to show that you can actually call from one person to the other and show the SIP protocol, right?
Yes.
Okay.
All right.
Alex, thank you.
Okay.
And now we have Belsy, and Belsy will talk about trusted crypto assets. Yeah. So finally, we are going to crypto space, and Belsy, stage is yours.
Hi, my name is Belsy, and the demo is on trusted crypto asset. I'll first sort of show what the logic is behind the demo, and then go through the demo because a lot happens behind the scene. A little bit of background, so a typical on-chain transaction, which you saw earlier on. You have a blockchain wallet. It signs some message which contains like the business logic, like sending a token, and then the signature and the nonce goes into the transaction, and if the transaction is valid, the decentralized application executes it. In our model, we basically want to have dApps, decentralized applications, to be compliant, and this might require identity proofing. So in that case, what we have come up with is that the decentralized application itself would know sort of what credential it needs to be compliant. And so the user who wants to interact with it will have to supply a proof. So from the bottom of the diagram, the user knows the application and they know if they have the credential to supply such a proof. And then they derive the proof, sends it as part of the message to their controlled smart contract wallet, which is an on-chain smart contract. And then the smart contract wallet forwards it to the decentralized application, which then queries the predefined verifier to verify this credential. Just a little note here, the user's wallet needs to self-issue a credential because we're using the link secret in AnonCred to make sure that the actual issuer and the person who's sending this proof are linked in some way. So we'll go to the demo here. So everything on chain is done on the Cosmos smart contract framework, and it's deployed on a Cosmos SDK-based chain. Here is a front-end architecture. So as said before, we need to basically the user needs to figure out like what credential requests to send them, the issuer, and also they need to self-issue their own credential, and we require that the self-issued, we as in the on-chain verifier, requires a self-issued credential have two known attributes, the controller address and then the wallet address, which is the controller of the smart contract wallet and then the wallet itself. And the wallet needs to store this in order for the verifier to verify. So we do a on-chain transaction to store this. And then on the other side, this is like a dummy trusted issuer, and they have other attributes like a name and age as well. So in the next step, we now sort of know as a user what credential proof we need to provide to interact with our DApp. So we basically create a credential request, and then the issuer would sign this credential. So now we have this credential in our wallets, and then this is just that data. And then now we could generate the proof. As I said before, the proof that goes on chain is actually a combination of the two subproofs, the KYC credential and also the self-issued credential, tying the external credential to my own account. So now we go ahead and create the proof. And then at some point, cool. So I just want to show like the proof data. This will not be a stage that will be actually in the wallet. So there are now two subproofs with the relevant attributes for the one for the KYC issuer and the second one for the self-issued credential, and then the link secret, linking them together. And then the next step is just to go. Now we're finally actually ready because we have all the data to commit this step. So we, also in this demo, the decentralized application it doesn't do anything. It basically just forwards the proof and then requests it back. But obviously you could imagine that wrapping any application in our framework, which comes with also the legal side of things. It has it's a asset smart contract, but also as Carsten has demonstrated, it could also be like a trusted issuer list. So then you're not just trusting like a Ethereum address, you're trusting the proof from a credential to control to be the state keepers of that list. So we want to, again, like this would not be an actual step. So we want to now basically send this proof on chain for the on-chain verifier to verify, and so the data that we're sending is it's a bunch of basically data for the proof, and then the on-chain verifier will come back to us and say if it's yes or no, and that was it. Cool. Just to note that the extension that we use in this demo, we developed it in Nymlab because we need to have an extension that talks to the DApp that acts as the smart contract wallet. So it's a separate sort of crypto wallet, which will have a mobile component that, again, Animal is helping with. So, yeah.
Belsy, thank you. There were plenty of innovations in your presentation, your demo. Quick questions, quick answers.
So like my first reaction when I saw that to present the credential, it involved like writing something on chain is like, oh, that's a bummer. Like I don't have to pay gas to write on chain. But my understanding is with Cosmos, like the chain that the presenter's using might be different than the chain that verifier is using because of interchain stuff? Like, is that
Yeah.
true? So the gas
Yeah.
model for the verifier could be completely different than the gas model for the, the gas model for the presenter might be different than the gas model for the verifier.
Yeah.
And they
Yeah.
could still, this could still happen. Is that true?
So in this case, we really wouldn't, because IBC doesn't work. If you do cross-chain transaction, it doesn't work in the same block. So you can't like reject immediately if the verifier says no. You have to call over, and then for the other chain's block to run, and then for it to like sort of call back. And so then there's issue with like what happens if the transaction gets stuck in the middle and then they get revoked. Like, so it should really be in the same chain, because COSM wasn't such that like all the messages it will revert totally. Unlike like EVM.
So if they do have to be on the same chain, then like practically speaking, how much does it cost in today's exchange rate in euros to be presenting a credential here that gets verified? Like, how much does it cost?
So like this is costing 8 to 10 times on top of the normal token transaction to verify, but also chains there are lots of, it doesn't cost as much as EVM, and
But like,
so
how much less?
Oh, like a lot less.
How
like
much a lot?
like you could set, for example, like if this is on like osmosis, that's 0. Like
What's osmosis? What is that?
that's one of the chains.
Cool.
Yeah.
Closer to 0.00005.
Yeah, like a lot less.
Excellent, Belsy.
Thank
Thank you
you
for this fantastic presentation with on-chain credentials.
Thank you.
And now we have Manu, and Manu will talk about verifiable credential issuer playground. Yeah, Manu, what's the playground?
It is a fun place for everyone to go and hang out. Let me get this stuff on the screen. All right, can you see this? Okay, everyone's tired, so I just want you to remember this one thing, chappy.io. If you go to chappy.io, you will be able to use this thing and play around with it and have fun in the playground. Okay, so chappy.io is a new site that we launched. One of the big things that we have to start doing as a community is we have to start interoperating with each other. We have to demonstrate actual interoperability, right? So we've got a lot of cool things going on in the community, but what a lot of our customers are asking us right now is, do you actually interoperate? Is this actually an open ecosystem? Show me all the wallets that interoperate. Show me all the issuers that interoperate. And in order to do that, as a community, we've released this new website called chappy.io. It tells you if you're a digital wallet, how you can use it, if you're an issuer, how you can integrate it. There are code examples for verifiers, for issuers. So all you need to do is click through on the site, and you can kind of learn how to use this to interoperate. But this demo isn't about Chappy. It's about the tooling that's available to all of you today, right? So up at the very top of Chappy.io, there's Try the Chappy Playground. And the Chappy Playground is an issuing playground, basically. It lets you use a variety of different wallets. So this is about open wallet choice. It lets you use a variety of different wallets. It lets you switch from a variety of different issuing backends. So we have 4 on the playground now. We've got 8 other companies that we're already demonstrating interop on for the VC Issuer API. And it lets you select from a variety of different credentials. Some of these are pre-generated that you can pick from, but there's an entry field down here where your company can add your own verifiable credential. You just add it as a template, and the site will send it to one of the issuers. The issuers will digitally sign it, send it back, and then you can put it in one of the wallets that shows up in the Chappy selector. Currently, we have support for the Verifiable Credential API. We're going to have support for OpenID very shortly. We support both web apps, and we support native apps. So If your developers are like, I don't know if I can use it, they don't have much of a reason not to be able to, right, at this point. Native apps, web apps, multiple different issuing backends. So,
React Native?
Sorry?
React Native?
React Native, it doesn't matter.
Yes.
But yes, it shouldn't matter. Like that's not, you can write your, web app in React Native and Angular, Vue, whatever. You can use whatever iPhone native app, Android native app. It doesn't matter, right? You should be able to plug it in to this website. So on the right here is just an example wallet. It could be any kind of wallet. To show you that this is an actual live demo, I'm going to refresh. That's what's in my wallet right now. This is on my personal machine, on my laptop. I've also got it up on my mobile phone. They're synced. So I've got an app here that's running my wallet. I've got an app here that's running my wallet. And I could use a variety of different wallets. So what I'm going to do here is I am going to select a credential, like the alumni credential. That's going to kind of show up here. And I'm going to use one of the issuing backends to generate it. Now, this is not our company's issuing infrastructure. It's other companies' issuing infrastructure, right? I'm going to generate the verifiable credential. And it creates a proof. This timestamp is from right now, right? So it's done a digital signature on a verifiable credential, which basically says I attended a certain university. I'm going to click Store in Wallet. The Chappie selector comes up. I've got only one wallet to select here. If I had other ones registered, they'd show up in the list too. I'm going to click Store in my wallet. My wallet then pops up here to say, hey, this site's trying to store a credential in your wallet. Do you want the credential to be stored in your wallet? I say yes, store it. And then I'll end up going back to the Chappie Playground. Now this has been stored in my wallet. I'll go ahead and refresh the wallet here and refresh my wallet here. And if everything went according to plan, I should have a new alumni credential, which shows up here, show up, right? So, and then I know it's tiny, but there's the alumni credential on my phone, right? Synced using encrypted data vaults, using authorization and capabilities, all technologies that we worked on together here at Rebooting the Web Trust. Now, the important thing about this is that anyone in here can use this today. It is a community tooling to ensure that we can actually interoperate. One of the things that we're using this for is there's this plugfest called the JFF Plugfest that's happening in the United States right now. There are 40 companies that are issuers and digital wallets, and we have to show that we can actually interoperate. And this website is being used as one of the mechanisms that we're using. We're using this tooling to demonstrate real interoperability. So that's it. That's basically the demo. I just moved the JFF credential into my wallet. Any questions on how to use the site or how to integrate with it?
Another question, please. Not sure whether or not you can provide the answer straight away, but I was wondering whether this stuff does for the user and the wallets what the EC service that Maaike presented does for issuers and verifiers.
Similar, but the only thing that actually shows up in this dialogue here, let me show. You don't have a NASCAR problem with this dialogue because the only thing that shows up, I did the selection automatically, the only thing that shows up in the selector are the wallets that the person has selected, right? So no NASCAR anything. Also no QR code anything. Nobody saw a QR code through the whole demo, right? So that's not a thing here either.
Except for the one there.
Thank you. Except for the movie ticket, and that's the movie ticket company's problem, not ours, right? This is a real ticket for a show that played 2 weeks ago, so sorry you can't go see the movie. Any other questions? Yeah.
Yes, do I understand correctly that if I would want to test this, for example, with our mobile app, I do first need to do some coding and register the app, or should I be able to just scan the QR code and wait, there's no QR code?
What kind of app do you have? What kind of app do you have is the question. So if you have a web app, it's some JavaScript that you inject into your web app, and you would use that to register the wallet. And then when this button was clicked, this store in wallet button was clicked, your web app would show up in the list. So you would be an option that showed up in this list.
Yeah, it's not a web app, it's a React Native mobile app.
If it's a React Native app today, you can click the Select Native App button and select your app, and you'll get a message that there's a storage request. In the future, we're going to try and move those native apps into this chooser here. Within the next 3 months, we believe we're going to have that feature. So whether or not you're a web app or a native app, you'll show up in the chooser and you click the button and your app is invoked with the storage request.
Yeah, Dimitri, final question from you. Quick question, quick answer.
Sure. No, it was to answer the. Okay. Oh, got it. For the cameras. You do have to add code to your React Native. You receive an intent, right? So but it works both on iOS and Android, and like there's a demo video out there.
Yep. Yes.
Excellent.
Exactly. Thank you, Dimitri.
Thank you, Dimitri. Manu. Big hand of applause again for Manu. And now we are moving from visual QR codes to image hashing technology for verifiable credentials. And over to Victor and Andrew.
Okay, thank you very much. Just as a disclaimer, you're going to see a lot of QR codes in this demo. but I hope, you understand the justification behind. So what we wanted to present today is the challenge that we wanted to solve, and the challenge was how to add an image into a verifiable credentials. So as you probably know, there are different techniques to add an image into a verifiable credential. Maybe the naive approach would be to embed it as a base 64, but maybe there are some implications into that. So we came up with a solution. This solution, the idea is that you pass the photo out of band. It is not inside the verifiable credential. The image can be verified offline, and you can verify that the image is authentic, meaning that the image that is presented to you is the same one that was used during the enrollment, and also that there is a link between the image and the QR code or the verifiable credential. And this technology is based on 2 building blocks mainly: image hashing and machine learning. And then also we wanted to take the angle of inclusivity, meaning this technology works cross-substrate, meaning you can print the image on paper, on a car, plastified car, or even you can show it on a screen. So how it works, the process. So there is an issuer. There is an enrollment process. In this enrollment process, the image has a high-quality image, and we calculate here what we call visual hash. This visual hash is this image hashing technology. This image hashing technology is something that is really well known on the let's say image processing industry. We use an algorithm. It's called digital cosine transformation, and you can think of image hashing as like the fingerprint or unique visual characteristics of a photo. And the nice thing of this image hashing is that we are able to compress it in really small payload of 32 bytes. And then what we do is we embed this on the verifiable credential as an attribute, and then we sign it. So this is the issuance or the verifiable credentials, and then how it works during the verification. So during the verification, the way it works is we are going to show the QR code. The QR code is just a verifiable credential encoded, and inside this QR code you have the visual hash. This is the reference visual hash, and because the credential is tamper-proof, you can trust this. And then what we're going to do is, on the spot, we are going to present, let's say, another image out of band. And what the verifier is going to do is, with an app, is going to calculate on the spot the visual hash of the image presented, and it's going to compare it with the image from the QR code, which is the reference visual hash. And then this is a probabilistic comparison, so it's not deterministic. Based on a probability, then the verifier can decide if the image presented, it was the same one that was using during the enrollment or not. And that's it. Now let's go to the demo. Maybe it's, yeah. So, okay, maybe first of all, here what you have is 3 ID cards. The QR code is verifiable credential. And then what you have is, let's say, the first one is, let's say, the authentic person. The second card is the same QR code, but with obvious impersonification. It's a different person. And then the third one, maybe it's not so obvious. It is a morph attack. It's the combination of the first face and the second face. So it's a way to try to impersonate someone by blending your face with the face of the other person. So now let's go to the demo. So first of all, maybe, yeah, we are going to scan the QR code. So we are going to verify the credential. Once the credential is verified, we are going to authenticate the image. And probably, maybe you need to. Okay. And it verifies with a 96.6%. As you see here, what we are doing is we are not calculating one visual hash. What we are doing is we are connecting to the video stream. We are processing a lot of images. We are calculating a lot of visual hashes, and we take the average, we discard outliers, and then we compare the final visual hash calculation with the one from the credential. So now let's go to another one. So we calculate, we first verify the credential, and then we try to authenticate the photo, and it's failing. And then the last one, which is the most difficult one, we verify the QR code, the credential, and then the photo. Sorry. I can see it. No. Demo fake. Oh, sorry. I need to. Let me. Okay.
49%.
Yeah.
Cool, Victor. We saw a lot of risk scoring and good demo. Excellent.
Yeah. Sorry. Yeah.
I personally like the scoring, the probability. Yeah, that's cool.
Yeah. So maybe we haven't seen it in the app, but you have a threshold. So you as a verifier, you can define your threshold.
Excellent. Super.
Yeah.
Now I have a lot of questions because we combined biometry with credentials. Quick questions, quick answers. Christopher.
Yeah, sort of 2 questions. Last time I looked into one of these visual hash technologies, there was a patent behind it. Second is, if there isn't a patent behind it, is this something you're planning on releasing as open source? Because there's several different visual hash. I mean, the last one I saw was 256 bytes. So
yeah. So actually, the European Commission is trying to standardize image hashing technology, and they are evaluating different algorithms. The 2 ones that the European Commission has selected is, without us knowing, is DCT, the digital cosine transformation, and the other one is called image wavelet. Now, in terms of cybersecurity, yes, we have identified what are the potential vector attacks, and we think that the vector attack is that a potential attacker, but let's say the algorithm DCT is well known. So the challenge here is how someone, let's say, proving different photos can fool the visual hash algorithm by presenting the photo and saying, and the algorithm saying, yes, it is this the same photo? But yeah, this is something that we have taken into account, and actually the industry as well is looking into that as a solution for putting images on credentials or on mobile driving licenses.
Yeah. So usually with 32 bytes, you've got a very rough
error metric, meaning that it's high set of false positives or false negatives, however you want to look at it. Are the things that we're seeing actual 32 byte tests, or are they 256 byte or higher?
No, it's 32 bytes.
Do you have a paper on? Can you point to the paper that has the error metrics on that?
I could show you what are our. So we have, let's say, what we have done is with biometric lab in Switzerland, different testing, and we have tested. Let's say the most challenging one is like with let's say obvious impersonification, which is really really easy to spot. We have also tested with twin photos. Twin people try to and the results are really really good, and. What we have tested is we have taken a different sample of photos, and what we have done is we have generated variation of these photos, meaning you take a photo and then you have different light conditions, different, for instance, light conditions, and then we have done like an intensive testing of order of magnitude of thousands of photos. So the results that we have that we got are very very promising. However, we want to continue improving, but I can show you more results, but we don't have any public paper, but we are working on it. Yeah, but I'm happy to share if you want, but the thing is, as a company, we cannot share this publicly for the time being. But the results we are getting are really promising, this is what I can tell.
One question is visual hash, the industry term for the...
Image hashing.
Because how do you do the calculation of similarity if it's a hash? Like...
It
use...
seems
it's not a hash in the way of a single string.
Okay, the question is, how much backwards possibilities are there for like reconstructing the face from the data you have?
Zero.
You cannot.
Zero. It's a multi-dimensional hash. What you do is you measure distances between X, Y, Z slots.
So,
it's also not specific to faces. This works with an image of anything. So
yeah.
There's applications beyond.
Visual hash is just zeros and ones, and the way we compare visual hashes is actually with machine learning. And the idea is we have trained a machine learning algorithm to train how to compare using distant metrics to visual hashes that are ones and zeros.
Final question, quick answer. Caspar.
I suspect a very short answer also. Would it also work with a slightly different photo of the same person?
No. It needs to say. So this is not biometrics. What this is trying to solve is the question: is the photo presented to you the same one that was using during enrollment? This is not biometrics. This is also really important because what was one of the requirements that we didn't want to touch biometrics, and this is one let's say layer of security that you can add on your solution. Then answering the question: is the photo presented the same one that the person that is in front of you? Then this can be solved by biometrics, or it can be solved by looking at the person and comparing. But this is just solving one problem. Is the photo presented to you the same one that was using during the enrollment? And the idea that this visual hash, you can embed it on a really payload with really low size.
So no. Victor,
yeah.
Andrew, thanks for the presentation. And now we are hearing to a presentation about credential rendering, and over to Charles. So Charles will present us credential rendering. So how do we present credentials? And Charles, stage is yours.
Hello, hi, I'm Charles Lehner, and I'm joined by... Yeah, I'm Ben Go, hey. Ben, and...
I'm Dimitri.
And we're dealing with rendering verifiable credentials using this approach proposed by Manu on CCG's mailing list here. And this is being expanded into a paper for this Rebooting the Web of Trust. We're exploring the idea of having a render property on a verifiable credential, which contains an object that is used to determine how to render the credential in a specific context, not JSON-LD context, specific media. So in particular, we have examples of, we're thinking of examples for audio rendering and tactile rendering, but mostly web-based rendering with SVG or HTML.
Or PDF.
PDF. The quick demo here shows a kind of playground-like application for using this, where we have a credential on the left and a template on the right that's SVG. If we modify the template, we see the result changes below. Thank you. And also, modifying the credential changes the output as well. Thanks. That's the SVG example. And here is one using HTML. And in this example, the template is contained inside the render object in the credential. And again, it renders below, this time with HTML. And modifying the concept of the credential or the template changes the result for this demo. And that's it. Thank you.
Thank you. This was speed dating presentation with a lot of rendering. I like the rendering. It's accessibility, UX, and yeah, brilliant. Questions about the rendering?
In your spec, have you considered specifying the render as a Apple Wallet PKPass file or a Google Wallet file? Because fundamentally it's the same thing. It's a JSON, and then you have metadata and a visual artifact that then gets loaded into the wallet app. So they have a container format for specifying it.
So that's a great feature request. The render property is pluggable, right?
Yeah.
So it contains like different types. So that would be another type.
That's what
so
I mean.
obviously
Yeah,
we don't have it working
it
for
is
the
a
demo.
suggestion, yeah. Like,
But
because I think
that sounds like a great idea.
That would be super cool.
And the paper might like have as next steps creating a registry of some kind.
Correct.
For that type of thing.
Great feature. This is a great example for a cross-site injection. Just keep in mind, we had this already implemented last year, and then some issuers came across and said, well, when we inject your JavaScript inside the rendering process, we can monitoring every time a credential is rendered. And what we have also done is we have outsourced the different types of rendering in a DIT document or another resource. So you could query them via your verifiable credential, so you can choose in the app how you want to render it, so you don't have to overload the app with a lot of data, so you could render it on demand. But great work.
So we're glad you brought that up. We have a considerable security considerations section at which we mention the embedding malicious scripts, so there's ways to mitigate.
Weirdly enough.
Not only for JavaScript, but also when loading external resources like images or so.
Likewise, that is another section for in the considerations. Thank you, though.
Weirdly enough, the Apple format is self-contained. It doesn't ask you or force you to get external assets. So it's actually designed to work completely without contacting anyone or dynamically loading anything.
The what format?
You can use VCs for the same thing.
What format?
Sorry?
What format?
Apple.
Passkey.
Oh.
Passkey,
Apple or
yeah.
Apple. No,
It's
not
the zip
passkey.
file, if I recall correctly.
Not passkey.
Okay.
It's slightly different, but like Google Wallet, same thing.
And okay.
Thanks.
Chris.
Okay, I just want to ask, don't you think that the decision on how to render the credential should be on the consumer side?
Can you ask that as a not a leading question?
Sorry, I didn't get it.
It could be on the consumer side. It might also be under the purview of the specification for the credential type. So we'd need to consider those options.
So it's a great question. The term is rendering hint, so the issuer is giving some hints. However, the rendering can also be driven off of the credential type, in which case the user's wallet preferences do come in to play as well. So we're trying to cover both sides, user wallet preferences and issuer suggestions.
And one thing we should put in here is like, and I will tomorrow, is like basically a proposal for an algorithm by which if you're rendering a credential you might want to follow this algorithm, which is like render the hint to the credential. If that doesn't exist, look to the type of the credential. Maybe the author of that credential type has a preferred render there. If that doesn't exist, maybe there's some sort of fallback strategy, and we could standardize that sort of like algorithm to, I think, accommodate your point.
I think it's a bit like web pages. You can override fonts and CSS, and worst case fall back to a family.
Excellent, cool. I think we will now go to the next speaker. Give a big hand of applause to Charles and his team. And now we hear about SSI credentials for portal login, for authentication and authorization to get access to a portal. And Andre will deliver his presentation.
Yeah, hello everyone. I know it's already late. Nevertheless, I want to show you some stuff, which is basically all QR code magic and deep link magic, if you want. So I'm going to show you some simple workflow to basically authenticate at a web page. It's a standard WordPress site, and I will just log in via SSI, do the regular QR code magic, get the connection, and send some data out of a credential, which is an event attendee credential that we've done for Hyperledger Global Forum, the Trust IP Summit there. And when I send the data, it does the useful and logs me into the website, which is basically a simple workflow. However, if you want to do this, you don't have some kind of a easy pluggable way to achieve this. And we have basically come up with an integration framework, which we call ESATO Soul, to basically enable all this. So we have created the comprehensive suite to integrate this, to actually talk to stuff that organizations have in their enterprises today. And you have seen the demo that Maaike and Oscar did with the ESATOS wallet. So we have the ESATOS wallet in conjunction with this framework to basically integrate into the existing enterprise IT landscape with protocols that are in place today, like SAML, like OpenID Connect, like SCIM, like having any type of LDAP, like an Active Directory on Azure AD, or you can provision into any database in JDBC. And we have basically implemented this as a standard framework so that you can plug and play it into your enterprise IT directly. And you can even decide where you want to run it. So we can run it for you. You can run it in any type of cloud or on premises. And it's a completely containerized web server-based application framework, which basically can be driven by UI or can also be completely driven by API calls. And so just that you see how it's managed. So you basically configure the application that you want to authenticate in. It can be hundreds, thousands, whatever. If you're in a big enterprise, you probably have hundreds. And you can define rules that do authentication or authorization to these websites or any type of applications. So just so that you see how it looks like in this UI. You don't need UI. As I said, you can code your own. And you basically can say you want to see certain data out of a verifiable credential so that the rule triggers that you're authenticated, authorized in the application. We have done also some cool stuff which I cannot show today, but I just wanted to point your attention to this thing here, Windows Credential Provider. This is a very cool feature. Unfortunately, I cannot demonstrate it here now, but you can actually sign in to your Windows machine with the credential process that I've just shown. So that was basically the very quick demo. Okay, some QR codes. I'd love to integrate the NFC functionality because it would be really cool to just put your smartphone next to your PC and get signed in if your security policy permits that. But I think that would be a cool feature to integrate, and I look forward to getting this into one of the next versions. Thanks.
Yeah, Andre. Lots of integration with real-world infrastructure. That's great for adoption. Caspar.
Thank you.
I also see OpenID Connect. Does this also use SIOP v2 and those things?
No, it basically talks the true SSI stuff on the SSI side, so DITCOM. And on the other side, it talks all the classic, I don't want to call it legacy, but classic protocols world. And on the SSI side, it's completely in the ARIES based with DITCOM and AnonCreds.
Yo, another quick question, quick answer. Over to you.
Yeah, regarding the phishing through QR code, of course, your demo and everyone using out-of-band QR code that should be signed, you should be scanned by smartphones are vulnerable to relay attack of that QR code. For now, we didn't find any other solution that telling people that they should only scan QR code that are presented by an extension, our browser extensions that verify the link between the source of the QR code and an URL that is encoded on the QR code.
Yeah. Thanks for the. Are you finished or should I comment or do you want to say? Yeah. Sorry. Thanks for giving me that question. Obviously, this is something that we've worked on quite extensively last year in some projects under ID Union and for the German Federal Chancellery. So we have conceptualized something called Trusted Verifier or even Trusted Issuer. It basically goes the same way. So we basically show the endpoint currently in the next version of the wallet, show the endpoint with a certificate that's on the other side, and we can set basically policy if what type of certificate you want to see. Obviously, this is classic PKI stuff, so we demand on the highest level of security something like an extended validation or a QREC certificate, which gives you the details of the legal entity that is behind the endpoint. However, I consider this only an interim solution because we are working also on something called DIT to LEI registry with the Global Legal Entity Identifier Foundation, so that you basically can revert back to a cryptographic link between an LEI and a DIT, so that you can directly pull the legal entity identity information into your agent. So that's going to be the cool thing, I think, on the horizon. And then we have something more like a trust framework that works.
You completely lost me, so we have to discuss this.
Sorry. Yeah, absolutely. There will be some follow-up discussions here. Andre, thank you.
My pleasure.
Brilliant. And now we only have 2 more presentations to go. Yeah. Next speaker is Marcus Sabadello. And Marcus will talk about GoDiddy.com's Universal DIT Operations Suite. And Marcus, over to you.
Okay, I thought I was last, but it sounds like I'm not last. But anyway, I know everybody wants to go home, so I'll make it fast. GoDiddy is another project that was afforded by eSSIF-Lab. In the beginning, it was called the Universal DIT SaaS, so Universal DIT Software as a Service, and that really tells you everything you need to know about it. It's basically a platform for performing all sorts of operations with DITs. Doesn't do anything with VCs or other stuff, so it's only about DITs, and there are roughly speaking 3 areas of functionality. One area is resolving and dereferencing, so it's a classic DIT resolver. You all know what that is. You put in a DIT, you get back the DIT document. There's a list of some example DIT methods that it supports, but it also has quite a lot of additional functionality related to resolving and dereferencing. Here's documentation, so it supports different DIT document representations. You can get a DIT document in JSON-LD, in JSON, in CBOR. It supports dereferencing, so you can give it a DIT with a fragment, and it will return not the full DIT document, but just the one public key or the one service from the DIT document. It supports a lot of DIT URL parameters, service, relative ref, version ID, version time, so you can resolve earlier versions of a DIT document. It supports a function for transforming the public keys in the DIT document. So if there is a DIT which has a public key encoded in base 58, for example, but you want to get it back in JWK or in multi-base, then this API can automatically transform it and return the DIT document accordingly. And you can combine these things in a number of ways. number of ways. So this is one area, resolving and dereferencing. A second thing is creating and managing DIDs. So you can create a DID. I can choose one of the supported DID methods, EPSI, INDI, SOV, VARIS1, Web, Key, JWK, ION. So for example, I will choose INDI. I can specify some options. I can specify what I want in the DID document. So for example, I want to add, when I create it, I want the DIDCOM service endpoint in my DID document. So I prepare the DID document, I select the INDI method, I specify some options, and then I click create, and then it GoDiddy backend communicates with the ledger and all of that. It creates the DID. I can see some data about the response, how the DID was created. I can see all my DIDs in a list, so there's also a hosted wallet. You can see I've already created quite a lot of DIDs. I can also update them, so I can go here, update. I can say, for example, now my DIDCOM service endpoint has changed. I now have a different DIDCOM service endpoint, and I also forgot the ID property, which is actually mandatory in a DID document. So now I want to do an update, right? I perform an update on the DID according to the DID INDI method. Again, there's some options, updated, and then it has been updated. And there's a hosted wallet, so GoDiddy can also manage the keys in the backend, but we also figured out an alternative architecture, which we call the client managed secret mode, which means that GoDiddy will do all the DID method specific functions, communicating with the ledger, constructing the data messages and so on, but the cryptographic operations and the key management can remain on the client side. So there's a bit of back and forth between a client of this service, and GoDiddy never sees the keys, but it helps you with everything else that's necessary for the DID method to work. And we did manage to implement this in a design and implement this in a universal way across different DID methods. And you can imagine some interesting automatic integration also with existing wallet interfaces, such as WebKMS, for example. You could connect this to a WebKMS, and the GoDiddy service helps you with the DID method operations, but it never sees the keys. And the third area of functionality is searching and tracking. So one thing I can do here, I will get the DID which I just created and updated, and I will put that here in search DIDs into a field where I can type a specific DID, and I can say display all the known versions. So it's looking at all the global DID data, and for one specific DID I can look up the history of that, and you can see I just created it a few minutes ago, and then actually it was updated twice. And I can look at each DID document at a specific point in time, and this works globally, so not just for the DIDs that you create on GoDiddy, but for all the DIDs globally. And you can also search not by an individual single DID, but for an entire DID method. For example, for DID INDI, you could list all the 10 latest DIDs that were created globally. You see some on our internal Danube test network, but there's also one on Danube Tech, and if you go back, you'll find ID Union and Sovereign Mainnet and so on. And in the API, there are many more advanced queries that you can do. You can say, for example, give me all the DIDs from the last 2 months which have a DIDCOM service endpoint or which have a specific verification key. You can imagine things like automatic tracking and getting notified when a DID document changes, and much more. And the data that you saw earlier from Saida that she analyzed also comes out of this. And that's it. Thank you.
Markus, real SaaS service, and question over there.
Yeah, actually, it's 2 questions if there's enough time. The one is, you mentioned like this generic interface to basically construct the whole transaction and then let the wallet or the client sign it. So I wanted to know if it's public and how it's called and how can I look it up. And the second is, I guess you guys manage integrations with different DID methods, or is it up to the DID method developers to come up to you and somehow decide on integration? Because my question then is, for instance, in the case of querying the history of a DID, do you hold an archive node for each of the blockchains that you need to look up, or how do you handle this history querying?
The historic queries, so we host nodes for some of the networks. in order to be able to track and search that data, but it's all public data, right? So that anyone can see that basically. Regarding the question of how open this is, and so this is based on the open source projects at the Universal Resolver, Universal Registrar. So means we basically shamelessly exploit the public contributions from the idealistic open source community. So much of this, a lot of this, some of this is proprietary and commercial, but a lot of this is supported by the diff Universal Resolver, Universal Registrar. You can see the links also here at the bottom. So much of this you can self-host, and the interface for the DID registration, the client-side signing, and all of that. The interface for that we've specified also in a public diff specification, DID registration. So it tries to generalize and define abstract functions for create, update, and deactivate with inputs and outputs, and it talks about these architectures with the client-side signing. So the interface is all open. The implementation is a mix of diff open source and our own product.
Thanks. I love this work, and I also love people in this community building successful businesses. Could you give us a little bit about this? I saw pricing on there. So, how are you experimenting in the business model?
Pricing. So it's a classic SaaS model where you can, it's a subscription based. You pay per transaction for certain packages. To some extent, it's free. You can use it for free for some extent. If you need certain more transactions, then there's a monthly fee, depending on what kind of transactions and how many transactions you need.
Do you mean read in transactions or write?
Both. There's a not every operation counts as one transaction, and this is something we're still figuring out, right? The business model. But our idea is that some operations like creating, registering a DID is more expensive than resolving a DID. So we're trying to model this in terms of how much transactions are counted for one operation.
Okay, fine.
BTCR is $30.
Final question, Mirko.
We're talking about traceability, etc. So using a universal resolver that does everything for me at GoDaddy.com sounds really great, but in the end, you are the one monitoring all my looked up DIDs. So is it really the good way from the SSI perspective to use just your service, or shouldn't there be multiple decentralized universal resolvers like we are used when we want to use a distributed network to lower the traceability?
It's an evil mass DID surveillance tool. It's the Google of DIDs, and Oscar funded it, so it's his fault. No, so yes, there's of course a more to some extent, of course, that's right. The service like this kind of contradicts the idea of decentralization. You can even use this for generating DID key, right, on a service, but so to some extent that's true. But I think there's a more nuanced answer to that. So it could be perhaps that this will be used for experimentation, for proofs of concept, and probably not for your super sensitive production DIDs. Also, like I said, the open source projects, you can self-host them. There are also many other code bases, right? This is not the only way how to create and resolve DIDs. There are many other code bases. We also offer this as an on-premise licensed solution. So then again, there's not a central database. And most importantly, of course, you can update the DIDs, right? So if a DID is in there and you update it to a new key, then you sort of take it away from there into your own wallet, and then it's not there anymore, right? And GoDaddy also can't stop you from transferring your DID elsewhere because you can update the DID document.
Markus, thank you. Now, finally, we go from the Google for DIDs to the dark, deep bottom of wallets with Christopher Allen. Chris, stage is yours.
Okay, so what I really want to talk about is the bottom of your wallets. I mean, right now, almost all of these wallets are hot with hot keys, oftentimes run in JavaScript, not at all timing attack resistant or other side channels. At best, you have a little bit of support from maybe one of these. This is a ledger, which is a 2-chip solution, which basically then executes all of your cryptographic operations in MicroPython and something that could be supply chain attacked. I can basically put this one in yours and pull this one out, et cetera. And you'd never know. So Blockchain Commons is really working at the very bottom, underneath all of your wallets, to try to create some interoperable standards for how we handle a lot of the cryptography and seeds and things of that nature that's below the levels of all the stuff that you've done, that you've seen so far. To a certain extent, we're trying to solve this classic XKCD problem, which is we're all relying that somebody else is going to do that little bit at the bottom to make it safe for us. And we don't want that to happen. We don't want that to get knocked out. So we've been working with silicon vendors at the bottom. We've been also working with new emerging companies. This is a $250 air-gapped wallet, has a camera on this side, has a color screen on this side, supports a number of the Blockchain Commons standards that I'm going to demonstrate to you in just a minute. They will be coming out with a version of this in which you can own. Right now, this is using their firmware. They'll be coming out with versions that you can use your own firmware for it. And I highly recommend you go look at this site for the video on how they're securing this and how they're doing supply chain security and doing all the different things there. But we're also working with new chip vendors that are trying to offer SecP, BLS, other future cryptography here. So, we've been talking a lot about QRs and the perils of QRs, and there are definitely a lot of perils. One of the things you will see in almost all of these different types of things, whether or not it's this QR or some of these things on my iPhone over here, are these life hashes. So life hash is a something you use in addition to all of those hexadecimal numbers that I've seen in a whole bunch of the bottom of your screens. Right now, you really can't rely on that. It's not too hard because most people are either going to look at the first 3 digits or the last 3 digits or whatever, and they're going to say it's the same. They're not going to compare it against it, etc. A life hash is designed to be readable in a wide variety of formats. So if you go to lifehash.info, you can just type in RWOT, and you will see live that there is the life hash for that text. And we've run it through lots of different types of things. It's a very deterministic, and yet a single bit will do massive changes in how you're doing it. It shouldn't be used by itself. Obviously, you know, I can probably program a stable diffusion thing to do some magic, but the combination of the partial hashes that you're already showing, and this is a very strong thing. So why is that important? So one of the things I can do here is that I can scan this image, and boom, it tells me, guess what? Now, can you from there see that this must be the same thing? What was sent to me is what it was promised right here. So that's an example of a way to use life hash. If you wanted to use it with regular QR codes, you could basically take the payload of the QR, put the image beside it, and try to create a standard where everybody basically first checks the life hash to see it actually is what it's promised to be. We've also been, that's why I knew a little bit about this other thing. We've been thinking about other methodologies where maybe, so for instance, this isn't actually the hash of the QR because it knows that this is a seed. This is the hash of the public key. So, so we're actually looking at a subset of the data for that to render that particular image. How am I doing on time?
Okay, 2 minutes.
Okay. So we have this. We've also been working on SSKR, which is a Shamir secret recovery standard. So you can see here that I have given to maybe several of my friends these little fragments. Once again, I can scan. I will scan this one. And you'll notice here that it's saying, hey, I recognize that this is a simple QR. I need to have at least one more. I have 3. This happens to be a 2 of 3. And I can very quickly go here. boom, guess what? I've got the same seed. Once again, the QR code prints fine. We've also rendered this on a black and white 200 by 200 screen using dithering. So it's really, really small, and it's still quite recognizable. It's really designed for that. So once again, I've confirmed, what I gave somebody is what I actually ended up getting returned in an SSKR. Future things we're working on, I have some examples of this using NFCs, so you can recover with with NFCs. We also can sign this data, so you could have a QR payload that is signed by the issuer that is separate from the certifications that might be in the payload, such as a verifiable credential. So if you're interested in these things at the bottom of the stack, we have regular meetings. The big project this quarter is to have people cooperatively store seeds. So if your company goes out of business, there's another company that is storing shards, not the whole seeds, shards, so that in the absence of your company being able to work with your customers can recover. So we're all mutually helping each other with seed management. That's it.
Thank you, Chris. And now the final round of questions. Yeah. We start with Martin and then over to Jack. Martin.
Did you think about combining the QR code with the live hash? That should be visually possible. And then
yeah, we've looked into that. I mean, just to give you sort of one of the other standards that we're working on right now. It's not as easy as you might think. This here is probably our most successful standard, which is only used in the Bitcoin world right now. But this is to deal with the problem of PSBTs being far larger than what are possible on a QR code. So we basically are doing this rendering that'll then allows me to have a full transaction partially signed. If I right now scan this, so it basically now is saying that this is a signature request, and you can't really see it over here, but this is a signature request. No seeds on this device can be used to derive keys that sign this transaction, et cetera. So there's this, this is just an example of the kinds of things that we're trying to solve. So yeah, we weren't able. We're also dealing with the fact that laptop cameras are really bad. And we end up not being able to do as dense QRs, whereas with this particular animated QR, we've done like a terabyte transfer using that between two phones, and it's actually not as bad as you might think. It's obviously, several orders of magnitude slower than an SSD, but it works. But only between two iPhones or two Androids with high quality cameras.
Do you support the BIP39 split mnemonic standard?
We do. I'll give this to you. So we support we support it indirectly. So we both wrote. They basically participated in our Barcelona and Prague workshops. The SLIP39 or BIP39? I'm sorry, maybe I'm confused.
Same.
Okay, so BIP39 is a single key recovery. In the book that Shannon and I wrote on smart custody, you write your single key on titanium so that it can survive a California wildfire, all that type of stuff. That's not good enough for multi-sig and a lot of these other different emerging technologies. We do SSKR, the underlying crypto is the same as what is used by SLIP39 from Trezor. The difference is they made a decision that there is no round tripping with SLIP39. Once you use their SLIP39, you're locked into, you can't go back to a BIP39. So you can't restore the seeds. It's all one way, all the way around. Whereas I can basically choose. I can either use the SSKR of this when I restore it, and then maybe I'm moving to a new device that doesn't support SSKR, and I can just use the regular byte, the regular BIP39 words. So we want the round tripping. We want reliability, no single points of failure, no single points of attack.
And do you support different derivation paths as well?
Yes. Okay. Didn't have time to show it, but the free app, this app is free this week, so don't buy it, or you can buy it next week and give us $5. But there's a developer mode on it, and it has something called crypto request. Yeah. So you can basically say, you choose the seed, I want this particular derivation, and we support all the standard derivations. And then in this dialog, you will note that, it's not on this one, but in a crypto request, it will tell you this is a known derivation, and or gosh, this is kind of weird. This might be safe. To be clear, this app is very much intended to be, a reference for these types of things. It does not assume a network connection. It can run offline. So it's not going to confirm Bitcoin transactions. It's not going to go out to the sovereign indie servers to do things. It's intended to do the crypto safely and separately.
So the app is Seed Tool, and it's iPhone only right now.
iPhone and Mac.
Yeah, so my question was if this is mostly, let's say, a research exercise, or if you're actually targeting a specific class of potential users. So are you planning to take over the people that today use the hardware wallet, or who are you targeting? Like, who would be using a solution like this?
We're representing a community of developers, so we are a not-for-profit. This is not intended to be a for-profit product. Instead, this is a reference for other companies to do this. So we already have about 8-9 developers who are doing that PSBT animated, ranging from these guys use it, a couple of what I would call second-tier wallets. The top cryptographic wallets are hardware wallets, are Ledger and Trezor, and they're kind of going their own way. I have no idea if they'll, but sort of the second tier, they're coming together and helping define requirements, and we're helping them coordinate to make these standards. Most of our financial patrons are cryptocurrencies. So NFT wallet, a biometric ring that you can tap it to do your Lightning transaction, some layer 2 type of wallet functions. So that's who our current financial base is from. But the intent, and that's what I've started really promoting here and in the last couple of months, is we need more identity wallet vendors who really care about the security at the bottom, so we can define the requirements as we write all these libraries. So all of this is open source in a variety of different formats. We also are getting security reviews done on them. We have a lot more to do.
This is awesome. I want to start using it right away. I think the last thing you mentioned supply chain attacks, and so my question is does this have reproducible builds?
Yes.
And
okay. So excuse me. You can't do reproducible builds with iOS. All of our apps have versions of the tool available for command line tools, and some of the base command line tools are reproducible builds. So, but it's one more step, but it's all available. One of the things we've been more concerned about is reproducible crypto. So all of our apps have the ability to turn on a deterministic switch, which makes the randomness not random. So you can make sure that the app that runs on the iPhone will give the same results as say the app that runs on LeafyKit. LeafyKit is a little Raspberry Pi-ish device that has no networking, no Bluetooth or whatever, and they'll give the same results, the same life hash for the same values. So we've been more focused on that than sort of a lot of the niggly details of trying to get everything we do be reproducible builds.
And it sounds like you're saying also no iOS app is going to give me that property.
No, because you have to change the app it gets changed when Apple has it. Apple might be able to do it, but we can't.
What's the hardware wallet
Oh, yeah, this is foundationdevices.com, and this is Passport is the actual this model. But we also have Proxy is coming out. I'd hope they were going to be here, but they're trying to finalize it. They're going to have a biometric ring fingerprint sensor when you put it on, unlocks the ring kind of like an iPhone does, and then you can do things like tap the ring against surfaces or whatever for various kinds of yes, I want to confirm, yes, I want to do that, I want to have authentication, etc. So we have a number of different companies.
So this was Rebooting Web of Trust 11 demo night, live from The Hague in Netherlands. And we saw a huge variety of different demos, from dark deep wallet to the Google for the DITs, to credential rendering, trusted issuer lists, to universal resolvers, the entire variety of all the technologies being developed in the Rebooting Web of Trust community. And yeah, glad that you joined us, and looking forward to connecting with you guys soon. Thank you and take care.